In this video, we are going to go through the Leaving Cert Higher Level Maths Exam, Paper 1 from 2015. The first thing we want to do on this paper is we need to write the make and model of our calculator in the box provided. So, whatever calculator you have, there should be some number, often near the top left corner, which will indicate the type of calculator you have. In my case, the number that I would write in this box is EL-W531. Question 1. Mary threw a ball onto level ground from a height of 2 meters. Each time the ball hit the ground, it bounced back up to 3/4 of the height of the previous bounce. Complete the table to show the maximum height in fraction form reached by the ball on each of the first 4 bounces. So we're shown in the diagram, she throws the ball from 2 meters, it bounces and reaches a height which will be 3/4 of the previous height. Then it'll bounce again and reach 3/4 of this height, and bounces again, so it'll reach 3/4 of this height, and so on. The first entry in the table is given to us at bounce 0, so before the ball bounces. The height of the ball is 2/1 meters, so that's 2 meters, which is what we're starting off with, this distance. After the first bounce, so after this bounce, what is the maximum height of the ball here? So each time that the ball bounces, it will reach 3/4 of the height of the previous bounce. So the previous bounce had a height of 2 meters, and we want 3/4 of 2 meters, which is 3/2 in fraction form. That's 3/2 or 1.5. So after the first bounce, it will have a height of 3/2 meters. Now the second bounce is going to have 3/4 of the height of the first bounce. So 3/4 of 3/2 meters, because that's the height of the first bounce, which gives us 9/8 meters. So the height after the second bounce will be 9/8 meters. For the third bounce, we want 3/4 multiplied by 9/8, because that's the height of the previous bounce, and we'll get 27/32 meters. And for the fourth bounce, we want 3/4 multiplied by 27/32, and that's equal to 81/128 meters. So 81/128 meters. So these are the 4 numbers that we're going to fill into each of these 4 boxes. So after the first bounce, it will have a height of 3/2. After the second bounce, 9/8. After the third bounce, 27/32. And after the fourth bounce, 81/128. Part B says find in meters the total vertical distance the ball had traveled when it hit the ground for the 5th time. So when the ball hits the ground for the 1, 2, 3, 4, 5th time, over here, how far has the ball traveled up and down? So it'll travel 2 meters here, then 3/2 meters up, and 3/2 meters down, then 9/8 meters up, and 9/8 meters down. So we just want to add up all of these distances to get the total vertical distance it travels. So it's going to go down 2 meters, it's then going to go up 3/2 meters, it's then going to come back down 3/2 meters. So it goes up and then down again 3/2 meters each time. It's then going to go up 9/8 meters and then back down 9/8 meters. So it goes up and then back down 9/8. It's then going to go up 27/32 and back down 27/32. So it's 27/32 up and 27 over 32 down. And then it will go up by 81 over 128, and then back down by 81 over 128. So it will be 81 over 128 up, and 81 over 128 down. So that is the total vertical distance that the ball has traveled when it hits the ground for the 5th time. So I'm now just going to write this in a slightly different way to make the computation slightly easier. So that will be equal to 2 plus 2 times 3 over 2 plus 9 over 8 plus 27 over 32 plus 81 over 128. So the reason I'm writing it this way is because for each of these numbers there will be 2 of them, so it will be 2 times each of these numbers. So that will be equal to 2 plus 2 times 3 over 2 plus 9 over 8 plus 27 over 32 plus 81 over 128. That is equal to 653 over 64. So the total vertical distance will be 653 over 64 meters. Part C. If the ball were to continue to bounce indefinitely, find in meters the total vertical distance it would travel. So, each time it bounces, it's going to be traveling a little bit further. So after each bounce, we will be adding something on. So we have a sum here that's going to keep growing as more bounces occur. We're told to calculate when the ball bounces indefinitely, so if the ball bounces infinitely many times, so what we're being asked to calculate is an infinite sum. Now whenever we talk about infinite sums, or whenever there's any question relating to infinite sums, the first thing we should think about is the formula for an infinite sum of a geometric series. So you can find that formula in your tables book, which will be provided by the exam invigilator. So you want to turn to the page of sequences and series, and we'll see under geometric sequences or series, there's a formula for S infinity, the infinite sum. So we want to try to use this in some way to perform this calculation. So to use this formula, we need to have a geometric series. Now we've written down the first few terms of this series, and in a geometric series, what that means is each term is obtained by multiplying the previous term by some common ratio. And we can see that that's not actually happening here when we write out the sum in its simplest form. Because to get from here to here, we would multiply 2 by 3/4. And then to get from this term to this term, we'd have to multiply by 1 because nothing changes. Then to get from here to here, we'd multiply by 3/4. And to get from here to here, we'd multiply by 1 because nothing changes. So we don't, strictly speaking, have a geometric series here. So to use our formula, we have to write it slightly differently so we can see our geometric series. So the total vertical distance will be equal to this sum if continued indefinitely. So that will be equal to 2 plus 3 over 2 plus 3 over 2 plus 9 over 8 plus 9 over 8 plus all the other terms. Now what I'm going to do is I'm going to write this in the same form I wrote it up above. So 2 plus 2 times each of these terms, because we'll see that each of these terms after the first one will be repeated. So that's going to be equal to 2 plus 2 times 3 over 2 plus 9 over 8 plus 27 over 32 plus infinitely many other terms. Now the reason I've written it this way is because now what we have in here is a geometric series. the reason we can see that is because each term will be 3/4 of the previous term. So to go from here to here, we multiply by 3/4. To go from here to here, we multiply by 3/4. To go from here to the next term, we'll again multiply by 3/4. So to get from each term to the next term, we'll multiply by a common ratio of 3/4. So in this series, we can use our formula. Now the formula that we're given is that S infinity equals A over 1 minus OR, where A is the first term in the series and OR is the common ratio. So in this case, A will be equal to the first term in the series, which will be 3/2, because remember, we're only considering this part as the geometric series. It's not 2, because even though when we write out the full sum, 2 would come first, 2 is still not first in the geometric series. This formula only applies to geometric series, so we can't have this 2 at the beginning. So the first term will be 3/2. The other thing we need is the common ratio, which is the number we multiply each term by to get the next term. The ratio will be 3/4, because to get from 3/2 to 9/8, we multiply by 3/4. And to get from 9/8 to 27/32, we multiply by 3/4, and so on. So here's the value for A, here's the value for OR. So our total vertical distance will be equal to 2 plus 2 times the infinite sum of our geometric series. And thanks to our formula, we know that that's equal to 2 plus 2 times A, which is 3/2, over 1 minus OR. So it's 1 minus, and OR is 3/4. We can now simplify this fraction. First off, I'm going to multiply the fraction in here by the 2 out here. So we get 3/2 times 2 over 1 minus 3/4 is 1/4. Now that's going to be equal to 2 plus 3/2 times 2 is just going to be equal to 3 over 1/4. We're now going to multiply the top and bottom of this fraction by 4. And the reason we're doing that is to get rid of this fraction in the denominator. If we multiply by 4, then the bottom of the big fraction will be 1/4 times 4, which will be 1. And any number divided by 1 is just that number. So that will remove the fraction from this question. So this will be equal to 2 plus 3 times 4 over 1/4 times 4. So that will be 2 plus 3 times 4 is 12, and 1/4 times 4 is just 1. So that's equal to 2 plus 12, which is 14. So the total vertical distance traveled is 14 meters. Question 2. Solve this equation and write any irrational solutions in the form a plus b root c, where a, b, and c are all integers. So we're being asked to solve the equation x cubed minus 3x squared minus 9x plus 11 equals 0. Now we're not given any further information about that, and on this course, whenever we're given a cubic equation without any further information, that means we have to use a trial and error method to find the first root of this equation. So the first thing I'm going to do is I'm going to change the notation slightly. So I'm going to bring in some function notation to say f of x is equal to x cubed minus 3x squared minus 9x plus 11. So we want to find the values of x for which f of x is equal to 0. Now, because we're not given any other information, we're going to have to try some values and see what happens. The first value we should try is 0. So we'll see what f of 0 is equal to. Now, f of 0 will be 0 cubed, that's 0, minus 3 times 0, that's also 0, minus 9 times 0, that's also 0, plus 11. So that will be 0 plus 11, which is not equal to 0. So f of 0 is not equal to 0, so 0 is not a root of this equation. Next, let's try f of 1. F of 1 will be equal to 1 cubed, which is 1, minus 3 times 1 squared, that's minus 3, minus 9 times 1, that's minus 9, and plus 11. Plus 11. That's going to be equal to 1 plus 11 is 12, minus 3 minus 9 is minus 12, that's going to be equal to 0. So f of 1 is equal to 0, so 1 is a root of this equation. This means we've found our first root of this equation. Now, if we hadn't found it at 1, the next number I would have tried would be minus 1, then 2, then minus 2, then 3, then minus 3, and so on until you get a number that makes f of that number equal to 0. At this level of exam, you will be fairly guaranteed that unless you're given some other information about the cubic equation, it will have a nice root that you can find using this method. So we have that f of 1 is equal to 0. So that means x equals 1 is a root of the equation. And that implies that x minus 1 is equal to 0. So if we look at this and we subtract 1 from both sides, then we'll get this. Now if x minus 1 is equal to 0, then our factor theorem will tell us that this is a factor of this equation because x equals 1 is a root of that equation. So what does it mean to know that x minus 1 is a factor of x cubed minus 3x squared minus 9x plus 11? Well, what that means is that x minus 1 multiplied by something will be equal to x cubed minus 3x squared minus 9x plus 11. So similarly, if we have a number, take the number 6 for instance, then a factor of 6 is a number like 3 that can be multiplied by something to get 6. In much the same way, a factor of some polynomial or some cubic equation can be multiplied by something to give that cubic equation. So what that means is x cubed minus 3x squared minus 9x plus 11 must be equal to x minus 1 multiplied by something. So we need to figure out what this is to have the right-hand side of the equation equal to the left-hand side of the equation. So the first thing we want to look at is over here, the highest power of x is 1, and over here, the highest power is 3. So to get x cubed on the left-hand side, we must have an x multiplied by an x squared on the right-hand side, because x times x squared will be equal to x cubed. We also need to have some number in these brackets, so that whenever we multiply minus 1 by that number, we'll get plus 11. That will make the left-hand side balance with the right-hand side. So the number that we multiply minus 1 by to get plus 11 will be minus 11. Now we've got x squareds and we've got numbers, so what we're missing from this bracket is some number of x's. So we're going to say plus t times x. And we're not choosing t for any particular reason, we just want some variable that we're going to find the value of. We've now made it so that when we multiply out the right-hand side of the equation, we should get something equivalent to the left-hand side of the equation. The only difference will be on the right-hand side, there will be this unknown variable t. So let's multiply out the right-hand side of the equation so that we can figure out what number t is representing. So the right-hand side will be equal to x times x squared gives x cubed. X times tx gives tx squared. And x times minus 11 is equal to minus 11x. We're then going to have minus 1 multiplied by x squared gives minus x squared. Minus 1 multiplied by tx is equal to minus tx. And minus 1 multiplied by minus 11 gives plus 11. So the reason we chose each of these values in this bracket here was so that we would end up with an x cubed and a plus 11 on either end, just like we have on the left-hand side. Now we're going to factorize this slightly so that it makes it more clear what numbers are coming from where. So we have 1x cubed, you'll have t minus 1x squared, t minus 1 times x squared. We'll have minus 11x and minus tx, so you'll have minus t minus 11x, and we'll have plus 11. So we've now written this in a similar form to this, whereby it's in decreasing powers of x, and we can see which coefficients correspond to each other. So that means is we can see what numbers are in front of x on the left-hand side, and that must be equal to whatever numbers are in front of x on the right-hand side. So, for instance, the number in front of x cubed is 1, and the number in front of x cubed here is also 1. So these are equal to each other. The number with no x's is 11, and the number with no x's is 11. And the part where this gets useful is when we equate the terms in front of the x squareds. So what we have on the left-hand side is that minus 3 is the coefficient of x squared. And that must be equal to, on the right-hand side, the coefficient of x squared, which is t minus 1. We can now add 1 to both sides, get that minus 2 is equal to t. We could also use the coefficients of the x's to get that minus t minus 11 is equal to minus 9. We would then add 11 to both sides to get minus t is equal to plus 2, and then multiply both sides by minus 1 to get t is equal to minus 2. So we have solved for the value of t that makes this equation balance. So we have that our function f of x is equal to x minus 1 multiplied by x squared minus 2x minus 11. So in this case, I've written minus 2 instead of t, and I've written f of x instead of the equation we were given. The reason I've written minus 2 is because we solved for t, and we found that the value for t is minus 2. So I've replaced t up here with minus 2 over here. Now we have that f of x is equal to 0 for some value of x. We already have one of those values, and that is x equals 1, which we solved for up above. So if x equals 1 is not the solution, then we must have that x squared minus 2x minus 11 is equal to 0. So that means if two things multiplied by each other are equal to 0, then at least one of them must be equal to 0. We know what it means for this one to be equal to 0. That gives us that x equals 1. So now we want to look at what does it mean for this one to be equal to 0. So we now need to solve what we have, which is a quadratic equation. To solve a quadratic equation, we have a formula which says that x equals minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. If you don't know that formula off by heart, it is in your tables book on the page with algebra. That's on page 20. It's at the top of that page here. where it says x equals minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. So in this case, b will be equal to minus 2, c will be equal to minus 11, and a will be equal to 1. So we have that x is equal to minus minus 2, which is 2, plus or minus the square root of b squared, that's minus 2 squared, which is 4, minus 4 times a, which is 1, times c, which is minus 11, divided by 2 times a, which is 1. And that's going to be equal to 2 plus or minus the square root of 4 minus 4 times 1 is 4, minus 4 times minus 11 is plus 44. We have plus 44. And on the bottom we have 2 times 1, which is 2. That's going to be equal to 2 plus or minus the square root of 48 divided by 2. We now want to simplify this square root by finding the largest square number, which is a factor of 48. So we want to go through all of our square numbers. We have 1 squared is 1. We have 2 squared, which is 4, which does divide 48. We have 3 squared, which is 9. We have 4 squared, which is 16, which is bigger than 4 and also divides 48. We're going to have 5 squared, which is 25, 6 squared, which is 36, and 7 squared, which is 49. So the biggest square number that is less than 48 and divides 48 is 16. So this is going to be equal to 2 plus or minus the square root of 16 times 3 over 2. Now the reason I wrote it that way is because this will be equal to 2 plus or minus the square root of 16 multiplied by the square root of 3, all divided by 2. So what I've done here is I've taken the square root sign that was over some multiple and I've applied it to each part of the multiple. Now the square root of 16 will be 4, so we've got 2 plus or minus 4 times the square root of 3 divided by 2. And we can now divide the top and the bottom by 2 to get 1 plus or minus 2 times the square root of 3. So we now have our 3 solutions for this equation. We have that x equals 1 from back at the beginning, or x equals 1 plus 2 times the square root of 3, or x equals 1 minus 2 times the square root of 3. So we have found 3 solutions, and for each of our irrational solutions, we have written them in the form required. Question 3. Let f of x be equal to minus x squared plus 12x minus 27, where x is a real number. Complete the table below. So we're given various values of x, and we have to compute the values of f of x. So the easiest way to do this is to use your calculator and to enter the function f of x into the calculator you are using. Now, depending on the type of calculator you use, you may need to do this a different way, but if you are using the same type of calculator that I am using, I'll show you the best way to do it using this brand of calculator. So the first value we want to calculate, and let's start with when x is equal to 4, because they've given us the corresponding value, f of x is equal to 5, so we should be able to verify that we've typed in the function correctly by putting 4 into this function and getting 5 out of this function. So the first thing we want to do is we want to press the number that we're going to start with. That's the number 4 in this case. The next thing we're going to do is we're going to press this button, STO. That means store. So we're going to store the number 4 in the variable x, which is above the button that says or CL. So you can see on screen there's a 4, there's an arrow, and there's the letter x. That means 4 is currently being stored in the variable x. We're then going to write out the equation that we're given. So we can clear the screen. And we want to say minus x squared. So to use the variable x, I'm first pressing this button alpha, and then the button RCL again. Next in the formula we have plus 12x, so we're going to say plus 12 and alpha and x. And then we want to say minus 27. Now we've stored that x is equal to 4, so when we press equals, the answer we should get is 5. So that is equal to 5, so we know we've got it correct. Next we want to say if 5 is x, then that expression evaluates to the number 8. So in the first box here, underneath the 5, we'll write the number 8. We then want to say if 6 is x, then the expression evaluates to 9. We're told that if 7 is x, then it evaluates to 8. So the next number we want to use is 8. So if we give the input of 8 into the function, we get the output of 5. And finally, if we put the input of 9 into the function, we get our output of 0. So the 4 empty spaces in the table will be filled in by 8, 9, 5, and 0. Different calculators do this in different ways, and if your calculator does not do that, then you can still do this out by hand by calculating minus 5 squared plus 12 times 5 minus 27 and putting your answer in here, and the same for 6, and the same for 8, and the same for 9. Part 2 says using the table that we've just filled out and the trapezoidal rule, find the approximate area of the region bounded by the graph of f and the x-axis. So we can see from the table that the y value for y equals f of x goes from 0 down to 0 again. So from 3 to 9, the function goes above the x-axis and then back down below the x-axis. So what we're being asked is, what is the area of the region bounded by the curve and the x-axis? Now we're asked to use the trapezoidal rule, so we want to go to our tables book. We want to go to the page of area approximations, that's page 12, and we'll see the trapezoidal rule is written out here. So this says the area is equal to h over 2, where h is the distance between each part of the partition, and that's multiplied by each of the heights of the various sections. So we have that the rule is that the area will be equal to h over 2 multiplied by y1 plus yn plus 2 times y2 plus y3 plus all the other values of y up to yn minus 1. There is our formula. Now in this case, we will have 9 different heights of the graph, so 9 different values of y, given as 0, 5, 8, 9, 8, 5, and 0. So for instance, y1 will be equal to 0, y2 will be equal to 5, and so on up to y9 will be equal to 0 again over here. The value for h is the distance between each consecutive term. So that's the distance is going to be 1, because 3 to 4 is a difference of 1, 4 to 5 we increase by 1, 5 to 6 we increase by 1. So our value of h will be equal to 1. So our area will be h over 2, that's 1 over 2, multiplied by y1 is 0, plus y9, which is also 0, plus 2, multiplied by y2 through 8. So that's 5, plus 8, plus 9, plus 8, plus 5. So that's going to be equal to a half times 2 is just 1, so that will be 5 plus 8 plus 9 plus 8 plus 5. Now we're going to have 5 plus 5 is 10, 8 plus 8 is 16, 16 plus 10 is 26, plus 9 is 35. So the region will be 35 square units. Next, we're asked to find the area under the curve by integration. So we're asked to integrate f of x with respect to x from 3 to 9. So that's going to be equal to the integral from 3 to 9 of minus x squared plus 12x minus 27 with respect to x. So when we have the integral of a sum, that's the same as the sum of each of the integrals. So that will be equal to minus the integral of x squared dx plus 12 times the integral of x dx minus 27 times the integral of dx. And each of these integrals will be evaluated from 3 to 9. Now that's going to be equal to, the first one is going to be minus integral of x squared. So it's minus x cubed over 3. And that will be evaluated from 3 to 9. We're then going to have plus 12 times the integral of x is x squared over 2. And that's evaluated from 3 to 9. And lastly, we're going to have minus 27. The integral of dx is just x, evaluated from 3 up to 9. Okay, we can now take some of the constants outside of these evaluations, because in integration and differentiation, we can take constants inside or outside of the integral and or derivative, and it won't change our answer. So that will be equal to minus 1/3 times x cubed from 3 to 9 plus 12 divided by 2 is 6 times x squared from 3 to 9 minus 27 times x from 3 to 9. And that's going to be equal to minus 1/3 times 9 cubed, 9 to the power of 3, is 729, minus 3 cubed, which is 27, plus 6 times 9 squared, which is 81, minus 3 squared, which is 9, minus 27 times 9 minus 3. 729 minus 27 is going to be equal to 702. 702 divided by 3 is 234. So you have minus 234. And we're going to have 81 minus 9 is equal to 72 times 6 is 432. And then over here we have 9 minus 3 is 6 times 27 is equal to 162. That's minus 162. 432 minus 234 minus 162 is equal to 36. So the integral is equal to 36 square units. Part 3 says using your answers above, find the percentage error in your approximation of the area correct to one decimal place. So, when we calculated the approximation using the trapezoidal rule, we got that the area was 35 square units. When we calculated it by integration, we got that it was 36 square units. So the error will be 36 minus 35, which will be 1. So the error will be 1 square unit. We want that as a percentage, so the percentage of error will be 1 out of 36, because there are 36 units in total, and we were off by 1 in our approximation. So the error will be 1 divided by 36. 1 divided by 36 is equal to 0.0277. So that's going to be equal to 0.0277, which is the same as 2.8% if we round it to the nearest decimal place. Question 4. The complex numbers Z1, Z2, and Z3 are such that 2 over Z1 is equal to 1 over Z2 plus 1 over Z3. We're also given that Z2 is equal to 2 plus 3i, and Z3 is equal to 3 minus 2i. We're then told to write Z1 in the form a plus bi, where a and b are integers. So to do that, we have Z1 on the left-hand side of this equation, so we want to rewrite the right-hand side of this equation in a way that's easier to deal with. So firstly, we have 1 over Z2, and we want to rewrite that in some nicer way, given that Z2 is equal to 2 plus 3i. So that's going to be equal to 1 over 2 plus 3i. Now whenever we're trying to divide by a complex number, as we are here, we're trying to divide 1 by the complex number Z2. To do this, we want to multiply the top and bottom of the fraction by the conjugate of the complex number. So what that means is we want to multiply the top and the bottom by some constant term, which is the conjugate of the complex number. The conjugate just means that we change the sign in front of the imaginary part. So if we have the complex number 2 plus 3i, its conjugate will be 2 minus 3i. So we multiply the top and bottom by 2 minus 3i. So on the top we have 1 multiplied by 2 minus 3i, so that's 2 minus 3i on top. And on the bottom we have 2 plus 3i times 2 minus 3i. So we have 2 plus 3i multiplied by 2 minus 3i. Okay, so that will be equal to 2 minus 3i divided by 2 multiplied by 2 is 4. 2 multiplied by minus 3i is minus 6i. Plus 3i multiplied by 2 is plus 6i. And 3i multiplied by minus 3i is minus 9i squared. Now we notice that we have plus 6i and minus 6i, so that's equal to 0. We also have I squared here, and I squared is equal to minus 1. So this fraction is equal to 2 minus 3i divided by 4 plus 9. The reason we have plus 9 is because I squared is equal to minus 1. Minus 1 times minus 9 is plus 9. So this is going to be equal to 2 minus 3i divided by 13. Now the reason that we multiplied both the top and bottom of this fraction by the conjugate of the complex number was so that we would end up with a real number on the bottom of the fraction. Whenever we multiply a complex number by its conjugate, we're going to get the real part squared plus the imaginary part squared. So the real part is 2, and when we multiply them together, we got 2 squared, which is 4. The imaginary part is 3, so when we multiply them together, we got 3 squared, which is 9. So we've written 1 over z2 as a complex number divided by a real number, instead of a real number divided by a complex number. And this number is much easier to work with, as we will see in a minute. So next we want to do essentially the same thing with z3. So we want to write that in a similar fashion. So we have 1 over z3 is equal to 1 over 3 minus 2i. Now we're going to multiply the top and bottom of that by the conjugate of the complex number, which will be 3 plus 2i. So on the top we'll have 1 multiplied by 3 plus 2i, which is 3 plus 2i. And on the bottom, because we're multiplying a complex number by its conjugate, we'll get the real part squared, so that's 3 squared, which is 9, plus the imaginary part squared, that's 2 squared equals to 4. So we'll have the real part squared plus the imaginary part squared. So now we can write this as 3 plus 2i divided by 13. Now we want to get z1 in the form a plus bi. So let's go back to the equation that we're given to figure out what z1 is, now that we've written both 1 over z2 and 1 over z3 in forms that are easy to deal with. So we have that 2 over z1 is equal to 1 over z2, which is equal to 2 minus 3i over 13, plus 1 over z3, which is equal to 3 plus 2i over 13. Adding these fractions together, we want to add the real parts together and the imaginary parts together, because the denominators in both of these fractions are the same. So that will be equal to 2 plus 3, which is 5, and 2 minus 3i, which is minus I. And that will be divided by 13. So we have 2 over z1 is equal to 5 minus I over 13. And because this is an equation, we can invert both sides, so turn both fractions upside down to get z1 over 2 will be equal to 13 over 5 minus I. We can then multiply both sides by 2 to get that z1 is equal to 26 over 5 minus I. So we now have an expression for z1, but it's not in the correct form a plus bi. So to get it that way, we want to do the same manipulation that we did up above, where we multiply both the top and the bottom of this fraction by the conjugate of the complex number. So that's going to be equal to 26 multiplied by the conjugate of the bottom, which is 5 plus I. Remember, to get the conjugate of a complex number, you just change the sign of the imaginary part. And then when we multiply the bottom by 5 plus I, we will get the real part squared. That's 5 squared, which is 25, plus the imaginary part squared, that's 1 squared, which is equal to 1. So this will be equal to 26 multiplied by 5 plus I over 26. We can now divide both the top and bottom by 26 to get that z1 is equal to 5 plus I. So we now have z1 in the correct form. Part B. Let omega be a complex number such that omega to the power of n is equal to 1, and omega itself is not equal to 1. Let s be equal to 1 plus omega squared plus all the other powers of omega up to omega to the power of n minus 1. Use the formula for the sum of finite geometric series to write the value of s in its simplest form. So the first thing we see is that this expression for s is a geometric series, because each term is obtained by multiplying the previous term by omega. So if we multiply 1 by omega, we get omega. If we multiply omega by omega, we get omega squared, and so on. So we want the formula for a finite geometric series. So to do that, we turn to page 22 of our tables book, and we'll see that the formula for the nth partial sum will be a times 1 minus or to the power of n divided by 1 minus or. The formula we're looking for is Sn is equal to a times 1 minus or to the power of n divided by 1 minus or. In this formula, a is the first term of the series, and or is the common ratio. So we've got that s is equal to 1 plus omega squared plus all the other terms up to omega to the power of n minus 1. Now there are n terms in this sequence, because if we look at each value, the number of the term is the power of omega minus 1. So for instance, this is the second term, it has omega to the power of 1. This is the third term, it has omega to the power of 2. So the nth term will have omega to the power of n minus 1. So this is an expression for Sn, the nth partial sum. So this will be equal to a, which is the first term. So a will be equal to the first term, 1. And or will be equal to the common ratio, the amount we multiply by to get from each one to the other. So that will be equal to omega. So the nth partial sum will be equal to a multiplied by 1 minus or to the n. So that's a multiplied by 1 minus or to the power of n. Or is omega. And that's divided by 1 minus or. Again, where or is equal to omega. So we have on the top 1 multiplied by anything is just that thing. So we have 1 minus omega to the power of n, but we're told that omega to the power of n is equal to 1. So that will be equal to 1 minus 1 over 1 minus omega. Well, 1 minus 1 is 0, so this is 0 divided by 1 minus omega, which will be equal to 0. So S will be equal to 0. Question 5. Solve the equation x is equal to the square root of x plus 6, where x is a real number. To do this, what we're going to do is we're going to square both sides first of all to get rid of this square root symbol. So we get that x squared is equal to x plus 6. We can then subtract these two terms from this side to get x squared minus x minus 6 is equal to 0. We can then factorize this. So we have x multiplied by x. The last term is minus 6. So the minus tells us that there will be different signs. And the 6 tells us that there will be two numbers that multiply to get 6. So in this case it will be 2 and minus 3. Because when we add these two terms together, 2 minus 3 gives us minus 1. This means that the solutions to this equation are x is equal to minus 2 or x is equal to 3. But there's a problem with this. In an equation where the highest power of x is 1, there will be one solution. In an equation where the highest power of x is 2, there will be two solutions. We've gotten two solutions, so we've got the solutions to this quadratic equation here. But what we were asked to get were the solutions to this original equation. So to find out which one is correct, we want to substitute each of these values back into the original equation to see which one makes it balance, because we know there can only be one solution to this equation. So first we want to take the square root of minus 2 plus 6. Which will be equal to the square root of 4, which will be equal to 2. So if x is equal to minus 2, then we'll have that minus 2 is equal to 2, which is false. If x is equal to 3, we take the square root of 3 plus 6, which is equal to the square root of 9, which is equal to 3. So the equation only balances if x is equal to 3. Part B, we're asked to differentiate x minus the square root of x plus 6. So we have x minus the square root of x plus 6. So if we let y equal to x minus the square root of x plus 6, then y will be equal to x minus x plus 6 to the power of a half. And so dy dx, the derivative, will be equal to the derivative of x, which is 1, minus the derivative of the square root of x plus 6. So to get that, we multiply by the power, and a half of x plus 6. Then we reduce the power by 1 to make it minus a half. And then we multiply by the derivative of whatever is inside the brackets, which in this case will be equal to 1. So now we want to simplify this. That will be equal to 1 minus a half multiplied by 1 over x plus 6 to the power of a half. So that will be equal to 1 minus 1 over 2 times the square root of x plus 6. Part C says find the coordinates of the turning point of the function y equals x minus the square root of x plus 6. So at a turning point, the derivative is equal to 0. So we have that dy dx equals 0 at the turning point. So when dy dx equals 0, that means 1 minus 1 over 2 times the square root of x plus 6 is also equal to 0, because that's equal to dy dx. Now we can add 1 over the 2 times the square root of x plus 6 to both sides to get that 1 is equal to 1 over 2 times the square root of x plus 6. We can then multiply both sides by 2 times the square root of x plus 6 to get that 2 root x plus 6 is equal to 1. We can then divide both sides by 2 to get that the square root of x plus 6 is equal to a half, and then we can square both sides to get that x plus 6 is equal to a quarter. We can then subtract 6 from both sides to get that x is equal to minus 5.75. And that is in fact greater than minus 6. So we have the x coordinate. Now we just need the y coordinate. So at x equal to minus 5.75, we have that y is equal to x minus the square root of x plus 6. So y will be equal to minus 5.75 minus square root of 6 minus 5.75 is a quarter. The square root of a quarter is a half. So that will be minus 5.75 minus 0.5. So that will be equal to minus 6.25. So the coordinates will be minus 5.75, comma, minus 6.25. Question 6. We're looking to borrow money from one of two banks. Each bank has a different repayment option for our loan. Bank A will charge a monthly interest rate of 0.35%, and we're asked to find correct three significant figures annual percentage rate that is equivalent to this monthly interest rate. So to do this, the first thing we want to do is we want to go to our formula and tables book. We want to turn to the page with financial mathematics. And we'll see at the top we have a formula for compound interest. It says F is equal to P multiplied by 1 plus I to the power of T. So our formula tells us that the final amount is equal to the principal multiplied by 1 plus the interest rate to the power of T, where T is the time. So in this question we're trying to calculate the annual percentage interest rate, the APR, that is equivalent to a monthly interest rate of 0.35%. So to do this, the easiest way is to assume that we have an initial principal of 1. So that means the initial amount invested, the principal, is equal to 1. So if we assume that the principal is equal to €1, then we know that the interest rate will be equal to 0.35%. So we want that as a decimal because that's easier to work with. So that's 0.0035 is 0.35% as a decimal. And the time will be equal to 12 months because we're comparing a monthly interest rate to an annual interest rate. And in every year there are 12 months. So the time frame we want to consider will be 12 months. So the final amount, the amount after it has accumulated interest, will be equal to the principal, that's 1, multiplied by 1, plus the interest rate, 0.0035, to the power of T, which is 12. So the final amount will be equal to 1.0035 to the power of 12. So 1.0035 to the power of 12 is equal to 1.0428. Is equal to 1.0428. So if we borrow a principal of €1 at an interest rate of 0.35% for 12 months, then the final amount we owe is equal to 1.0428. So that's equal to our principal plus 0.0428. Or another way of writing that will be our principal plus 4.28% of the principal. So the annual percentage rate equivalent to a monthly interest rate of 0.35% will be 4.28%, because after 1 year the principal has increased by 4.28%. Part 2, Bank B will charge us a monthly rate that is equivalent to an APR of 4.5. Recall that APR just means the annual percentage rate. That's what we calculated in the last question. So now we want to find correct to three significant figures the monthly interest rate that is equivalent to an APR of 4.5. So again, we want to assume that our principal will be equal to 1. Now in this case, we know that the final amount will be equal to 1 plus 4.5% of the principal. That's 4.5% of 1 is 0.045. We also know the time will be equal to 12 months because we're talking about 1 year again, so the time will be 12 months, and we're trying to find the value of I, the interest rate, for each month. So using our formula, we have that the final amount, 1.045, will be equal to the principal, that's 1, multiplied by 1 plus the interest rate, to the power of T, which is 12. So 1.045 is equal to 1 plus I to the power of 12. Then we take the 12th root of both sides, or equivalently, we raise both sides to the power of 1 over 12, and we get 1.045 to the power of 1 over 12 is equal to 1 plus I. We then subtract 1 from both sides to get that I is equal to 1.045 to the power of 1 over 12 minus 1. So I will be equal to 1.045 to the power of 1 over 12 minus 1, which is equal to 0.0036748. Now we want that as a percentage, and we have it as a decimal. We also only want it to 3 significant figures, so I will be equal to 0.367%. So that is the monthly interest rate. That will be equivalent to an annual interest rate of 4.5. Part B. We borrow 80,000 at a monthly interest rate of 0.35, fixed for the term of a loan from Bank A. The loan is to be repaid in equal monthly repayments over 10 years. The first repayment is due 1 month after the loan is issued. Calculate correct to the nearest euro the amount of each monthly repayment. So to do this, we want to go to our formula and tables book again. And again, we want to turn to the page of financial mathematics. This time we want to look at the other page where we're looking at mortgages and loans. And we're told that the annual repayment amount will be equal to this value here. So the annual repayment amount will be equal to the principal multiplied by I times 1 plus I to the power of t divided by 1 plus I to the power of t minus 1, where I is the interest rate and t is the time. So in this case, the principal amount that we borrow is equal to 80,000. The interest rate will be equal to 0.35%. So we want that as a decimal, so that's 0.0035. And the time will be equal to the number of months in 10 years, which is 120 months. The reason we have to break this down by month instead of just by year is because our interest rate is 0.35 per month. So the value of I here will be per month, so our time value has to also be in months. So the amount to be repaid will be equal to the principal, that's 80,000, multiplied by the interest rate, 0.0035, times 1 plus the interest rate, 0.0035, to the power of t, which is 120, all divided by 1 plus the interest rate, which is 0.0035, to the power of t, which is 120, minus 1. So that's going to be equal to 80,000 multiplied by 0.0035 times 1.0035 to the power of 120 divided by 1.0035 to the power of 120 minus 1. So that's going to be equal to 80,000 multiplied by 0.0035 multiplied by 1.0035 to the power of 120, which is 1.52085, divided by 1.0035 to the power of 120, which again is 1.52085 minus 1. So that's going to be equal to 80,000 multiplied by 0.0035 times 1.52085 to get 0.005323 over 0.52085. So that's going to be 80,000 multiplied by 0.005323 divided by 0.52085, which is equal to 0.0102. That multiplied by 80,000 is equal to 817.56, and to the nearest euro, that will be 818 euros. So the amount that has to be repaid at the end of each month will be 818 euros. Question 7. A plane is flying horizontally at P at a height of 150 meters above the ground. P is 5 kilometers horizontally from the point of touchdown O. When the plane lands at O, it will be horizontal. Taking O as the origin, the set of points x, f of x, approximately describes the path of the plane's descent, where f of x is given by this function. So we're given a function f of x, and this describes the plane's descent from the point P, which is 0.15 kilometers up in the air and 5 kilometers away from the origin. In part A, we're asked to show that d is equal to 0. So the function that we're given to describe the plane's descent is f of x is equal to 0.0024 x cubed plus 0.018 x squared plus cx plus d. And we're asked to show that d is equal to 0. So to do this, the first thing we want to note is that the origin, O, is on this graph. So the plane starts up at point P and then descends and lands at the origin at the point 0, 0. So what that means is the point 0, 0 is in this form. X f of x at some point is equal to 0, 0. So what that means is when we put 0 into this function, the output will also be 0. So 0 is on the curve, so f of 0 must be equal to 0 because the point 0, 0 is on the curve. So the input and the output must both be 0. But f of 0 is equal to 0.0024 times 0 cubed plus 0.018 times 0 squared plus c times 0 plus d. So that will be equal to 0 plus 0 plus 0 plus d. So 0 plus 0 plus 0 plus d. Because each time it's some number multiplied by 0, we will get 0. So f of 0 is equal to d, and f of 0 is equal to 0. Therefore, d must be equal to 0. Next, we're told that P is the point minus 5, 0.15. So the point P is 5 in the negative x direction and 0.15 in the positive y direction. Given that these are the coordinates of the point P, we're asked to show that C is equal to 0. So what that means is f of minus 5, the x-coordinate, must be equal to 0.15, because these are the coordinates of P, and P is on this curve. So now let's evaluate what is f of minus 5. That's going to be equal to 0.0024 times minus 5 cubed plus 0.018 times minus 5 squared plus c times minus 5 plus d, but we found from the last part that d is 0, so it's plus 0, so we don't need to write that down. So that's going to be equal to 0.0024 multiplied by 5 times 5 times 5 is 125, so we have minus 125 plus 0.018 multiplied by minus 5 squared is plus 25, and c times minus 5 is minus 5c. So 125 multiplied by 0.0024 is going to be equal to 0.3. So this will be minus 0.3 plus 0.018 multiplied by 25, which is 0.45, minus 5c. So this will be equal to 0.45 minus 0.3 is 0.15 minus 5c. So we get that f of minus 5 is 0.15 minus 5c, but we know that f of minus 5 is 0.15, so we have that 0.15 must be equal to 0.15 minus 5c. We can then subtract 0.15 from both sides of this equation to get that minus 5c is equal to 0, and then divide both sides by minus 5 to get that c is equal to 0. So we have that both d and c are equal to 0. Part B, we're asked to find the value of f dash x, the derivative of f of x, and we're asked to find that value when x is equal to minus 4. So the first thing we want to do, we're going to rewrite f of x without these last two terms, because we know both c and d are equal to 0. So we now know that f of x is equal to 0.0024 x cubed plus 0.018 x squared. The last two terms are both equal to 0 because both c and d are equal to 0, and we know that from part A. We now want to find the derivative of this, so we want to get f dash of x, and to do that, for each amount of x, we're going to multiply by the power and then reduce the power by 1. So the first thing we're going to do is, for x cubed, we multiply by the power, so that's 3 multiplied by the number in front of the x, which is 0.0024, and then we want to reduce the power of x by 1, so it goes from 3 down to 2. We then want to do the same with this, so we're going to multiply by the power, which is 2. The number in front stays the same, and then we're going to reduce the power of x by 1, so it goes from 2 down to 1, and we don't need to write in a power of 1 because x is equal to x to the power of 1. So we have 3 times 0.0024, which is equal to 0.0072 x squared, and then we have 2 times 0.018, which is going to equal to 0.036. So that's going to be plus 0.036 x. we next want to find what is the value of f dash x at x is equal to minus 4. So f dash of minus 4 will be equal to 0.0072 times minus 4 squared plus 0.036 times minus 4. So that will be equal to 0.0072 multiplied by minus 4 squared, which is 16, minus 0.036 multiplied by 4. So that will be equal to 0.0072 multiplied by 16, which is 0.1152, minus 0.036 times 4, which is 0.144. So we have 0.1152 minus 0.144, which is equal to minus 0.0288. Part 2 says, using your answer from B Part 1, find the angle at which the plane is descending when it is 4 kilometers from touchdown. Give your answer correct to the nearest degree. So we want to find the angle of descent. The first thing we're going to do is we're just going to remember that f dash of x is equal to 0.0072x squared plus 0.036x, and we found that f dash of minus 4 is equal to minus 0.0288. So we want to use this answer in some way to find the angle at which the plane is descending when it is 4 kilometers from touchdown. So we want to find the angle of descent. Now, what does it mean to be looking for the angle of descent? Well, if we imagine here's the point P, and the plane goes this way, and then it starts descending, and it comes into landing at the origin. We draw in our axes here. And we're going to have our point P over here at minus 5, and it's going to have a height of 0.15. Then slightly after that, 4 kilometers from touchdown at minus 4. Here's where the plane is going to be. So the direction it's going is going to be this way. It's going to be going in this sort of a direction at that time. And what we're looking for is the angle of descent. So we're looking for this angle here, which I'm going to call alpha. So how far down is the plane facing at this exact moment? Well, we know that f dash of minus 4 is minus 0.0288. And one of the things we also know is that the slope will be equal to the derivative. So the slope at minus 4 will be equal to the derivative, because that's what the derivative is. What the derivative of a function is the slope of that function at any one time. So at this particular time, what is the slope of the function? Another thing we know is that the slope will be equal to the tan of the angle the line makes in the positive direction, which I'm going to call theta. So the slope will be equal to the tan of this angle, theta. So combining these two things, we get that tan theta will be equal to f dash of minus 4. Now we know that f dash of minus 4 is minus 0.0288. So we have the tan theta is equal to minus 0.0288. So now what we want to do is we want to find the value of theta for which this is true, and then we can use that to find the value of alpha, which is the angle of descent that we're asked for. So we know that tan theta is equal to minus 0.0288. So to find theta, the first thing we want to do is we want to find our reference angle, and then we can use that to find the specific angle that we're looking for. To do this, what we're going to do is, first of all, we're going to forget about this minus sign for a second, and we're going to see, well, what if tan theta is equal to 0.0288 without the minus sign? Well, then theta will be equal to tan inverse 0.0288, which will be equal to tan inverse 0.0288, which will be 1.65. So the reference angle is 1.65 degrees. Now, if we imagine our unit circle, then we know all of the functions are positive in this quadrant. Sine is positive in this quadrant. Cosine is positive in this quadrant. And tan is positive in this quadrant. So because our value is negative, we know that it must be in one of these two quadrants. That means that we have either this angle here is 1.65, or this angle down here is 1.65. And that means that our angle theta will be this angle here. So that's 180 minus 1.65 is 178.35 degrees. Now that we know theta, we can easily find alpha, because if we imagine this line going off here, then alpha will be both this angle and this angle, because they form alternate angles. So this Z shape here, so they're both alternate angles. So 180 minus theta will be equal to alpha. So alpha will be equal to 1.65. And they want that to the nearest degree. So that means the angle of descent will be equal to 2 degrees at x equals minus 4. Part C. We're asked to show that minus 2.5, 0.075 is the point of inflection of this curve. And we know that at the point of inflection, the second derivative with respect to x will be equal to 0. So to do this, we want to find the second derivative and then set that equal to 0 and solve for x. Then we can use that value of x to find the value for y. And then we should get out this point as a result. So the first thing we want to do is find f dash dash x. We have f dash of x is equal to 0.0072x squared plus 0.036x. So you want to take the derivative of that, get f dash dash of x will be equal to, and we have x squared, so we want to multiply by the power, which is 2, 0.0072, and then we want to reduce the power of x by 1, so 2 minus 1 is just 1, and then here we have x to the power of 1, so the x just disappears when we differentiate to get 0.036. So the second derivative is going to be equal to 0.0144x plus 0.036. Now we're looking for the point of inflection, so we want to set f dash dash of x equal to 0, because that's always true at the point of inflection. So we get that 0.0144x plus 0.036 is equal to 0. So we want the second derivative of the function to be equal to 0. Now to solve this, we're going to subtract 0.036 from both sides. So you have 0.0144x is equal to minus 0.036. We're then going to divide both sides by 0.0144 to get the x is equal to minus 0.036 over 0.0144. So 0.036 divided by 0.0144 is equal to 2.5. So x equals minus 2.5. So we have our desired value for x. We have that x is equal to minus 2.5. As required, the x value here is minus 2.5. So now we want to show that the y value is 0.075. So what that means is when we put minus 2.5 into the original function, we get out 0.075. Now, the original function, f of x, is equal to 0.0024x cubed plus 0.018x squared. So f of minus 2.5 should be equal to 0.075. Now let's verify that. So we have 0.0024 times minus 2.5 cubed plus 0.018 times minus 2.5 squared. So that will be equal to 0.0024 multiplied by minus 2.5 to the power of 3, which is equal to minus 15.625. Plus 0.018 times minus 2.5 squared, which is 6.25. So that's going to be equal to 0.0024 times 15.625 is equal to 0.0375. So that will be minus 0.0375 plus 0.018 times 6.25 is going to be equal to 0.1125. So 0.1125 minus 0.0375 is going to be equal to 0.075, which is the value we were looking for. So therefore, the point of inflection is equal to minus 2.5, comma 0.075. Part D. If xy is a point on the curve y equals f of x, verify that minus x minus 5 minus y plus 0.15 is also a point on y equals f of x. So what this means is, if we take our function and we put in x, we get out y. Given that, if we put in minus x minus 5, we should get out minus y plus 0.15. And if that happens, then this point will be on this curve. So firstly, we need to know what function we're working with. So the function from the previous part is f of x is equal to 0.0024x cubed plus 0.018x squared. So there's our function. So we want to see what is f of minus x minus 5. Well, that's going to be equal to 0.0024 times minus x minus 5 cubed plus 0.018 times minus x minus 5 squared. Okay, to evaluate this, there are two options. Either we can multiply this out by hand, or we can use our formula that says a plus b cubed will be equal to a cubed plus 3a squared b plus 3ab squared plus b cubed. And that formula comes directly from the binomial theorem. This is a formula that comes directly from the binomial theorem. When we're trying to evaluate a plus b to a power, we can use the binomial theorem, but it is often useful to know the specific formulas for some of the lower powers. So this is going to be equal to 0.0024 multiplied by, and this is a plus b cubed, so this is the first thing cubed, so that's minus x to the power of 3, plus 3 times the first thing squared, so that's minus x squared, multiplied by the second thing, which is minus 5. Then we're going to have plus 3 times the first thing, multiplied by the second thing squared, plus the second thing cubed. So there it is. You could also multiply this out by hand by writing out the brackets 3 times and going through the entire computation, or you could use the binomial theorem, applying it to this. You'll get out this formula, and then you can apply it to get this result. So it will be that plus 0.018 times, and again we're going to use another formula which comes directly from the binomial theorem, which says that a plus b squared will be equal to a squared plus 2ab plus b squared. That one should be more familiar, but these two formulas both come from the same place. They come from the binomial theorem. So when we want to evaluate minus x minus 5 squared, that will be the first thing squared, so that's minus x squared is x squared, plus twice the product, so that's twice 2 times x times 5, because the minuses cancel each other out, plus minus 5 squared, which is 25. So that's going to be equal to 0.0024 times minus x cubed minus 15x squared minus 75x minus 5 cubed, which is 125, plus 0.018 times x squared plus 10x plus 25. So that will be equal to minus 0.0024 x cubed then we're going to have minus 15 times 0.0024, which will be 0.036x squared minus 75 times 0.0024, which will be 0.18x, and then we're going to have 125 times 0.0024, which is 0.3, so minus 0.3. Then to that we're going to add on 0.018 x squared plus 0.036 0.18x plus 25 times 0.018, which is going to be 0.45. Now we can simplify this. So we get that this is equal to minus 0.0024x cubed. And we've got x squareds here and x squareds here. So that's going to be 36 minus 18 is 18. That's going to be minus 0.018x squared. Then for our x's, we've got minus 0.18 here and plus 0.18 here. So that'll be equal to 0. And then we're going to have 0.45 minus 0.3 to have plus 0.15. Now that is going to be equal to minus 0.0024x cubed plus 0.018x squared plus 0.15. This part here between the square brackets, well, that's going to be equal to f of x, 0.0024x cubed plus 0.018x squared. And we know that f of x is equal to y, so this is going to be equal to minus y plus 0.15. So therefore, the point minus x minus 5 comma minus y plus 0.15 is on the curve y is equal to f of x. Finally, we're asked to find the image of this point under symmetry in the point of inflection. So we know what the point of inflection is, and we know what the point is. So the first thing we have the point will be equal to minus x minus 5 minus y plus 0.15. So we're asked to find the image of this point in the point of inflection. Point of inflection we found from the previous part of the question. Point of inflection we found to be minus 2.5 comma 0.075. There's the point and the point of inflection. So we want to find the image of this point. So the idea is we have our curve that looks something like this. We have the point of inflection will be here in the middle. The point of inflection. We're going to have our initial point, and we're going to get the image of this point under symmetry in the point of inflection. So we should get something over here, the image. So when we're trying to find the image of some point reflected in anything, we want to see what is the change going from the point to the point of inflection, and then the same amount of change will happen on the other side. So we're going to have some change in the x value, and then we're going to have the same amount of change in the x value again to get to the image. Similarly, we're going to have some change in the y value, and then we're going to have the same change to get to the image. So, change in x, change in the x direction here, is going to be the difference between the x-coordinate of this point and the x-coordinate of this point. So the x-coordinate of this point is minus 2.5, and we want to take the difference between that. The difference means we subtract minus x minus 5. The x-coordinate of the point. So the difference between these two will be the change in x. Well, that's going to be equal to minus x, which is plus x, and minus 5 is plus 5, minus 2.5 is plus 2.5. So the change in x will be x plus 2.5. So then from here to here, we're going to have the same change in x. So the same change is going to be from the point of inflection to the image. So that's going to be from minus 2.5. And this time we're adding on, because we're going in this direction, adding on x plus 2.5. So that's going to be equal to x plus 2.5 minus 2.5, so that's just going to be equal to x. Next, we want to look at the change in y. This amount, and again, we want to take the difference between the point of inflection and the point. So the y-coordinate in the point of inflection will be 0.075 minus the y-coordinate of the point, which will be minus y plus 0.15. So that's going to be equal to minus y is plus y, 0.075 minus 0.15 is going to be minus 0.075, because this is exactly twice that, so we're taking away half and left with the other half. So then we want the same change in the y direction, so from here to here, at this point, we're going to start at the point of inflection, so the y-coordinate will be 0.075, and then we're going to add on y minus 0.075, the change. So now we're going to have y plus 0.075 minus 0.075, so that's just going to be equal to y. Therefore, the image is going to be equal to x, y. So what this is saying is the image of the point is also going to be on the curve. Question 8. An oil spill occurs offshore in an area of calm water with no currents. The oil is spilling at a rate of 4 by 10 to the power of 6 centimeters cubed per minute. So that number there, 4 by 10 to the power of 6, that just means 4 followed by 6 zeros, or 4 million centimeters cubed per minute. The oil floats on top of the water. Complete the table below to show the total volume of oil on the water after each of the first 6 minutes. So we're given a table. On the top row there is the time measured in minutes since the oil spill occurred. So we have 1, 2, 3, 4, 5, 6 minutes. And on the bottom we have the volume of oil in million centimeters cubed. So this is by 10 to the power of 6. That just means 6 zeros, which is 1 million. So after 1 minute, there will be 4 by 10 to the power of 6 centimeters cubed. So it will be 4 that goes in this box. We're told that after 2 minutes, there will be 8 by 10 to the power of 6, because there will be twice as much. And then in each consecutive minute, we'll be adding on another 4, because it goes from 4 to 8. Next, it will be 12, and 16, and 20, and 24. Because after each minute, there is another 4 by 10 to the power of 6 centimeters cubed. So after the first minute, there will be 4. After the second minute, there will be 8. After the third, there will be 12. After the fourth, there will be 16. After the fifth, there will be 20. And after the sixth, there will be 24. So that means each of these numbers is what goes in the boxes, So for instance, here we have 16. That means there are 16 by 10 to the power of 6 centimeters cubed of oil, or equivalently 16 followed by 6 zeros, which is 16 million centimeters cubed of oil after 1, 2, 3, 4 minutes. Next, we're asked to plot this information on the given graph. So we have the same scales on our axes. On the x-axis we have time in minutes, and on the y-axis we have volume in million centimeters cubed. So after 1 minute there will be 4 million centimeters cubed. After 2 there will be 8. After 3 there will be 12. After 4 there will be 16. After 5 there will be 20. And after 6 there will be 24. We then want to join all of these dots to get our graph. And we should note that the point 0, 0 is also on this graph, because at 0 minutes there will be no oil on the water. Part 3, we're asked to write an equation for V of t, the volume of oil on the water, after t minutes. So what that means is we want to write down a function, V of t, such that whenever we give it some value of t, it will give us how much oil is on the water. So we need some function, v, such that v of 1 is 4 by 10 to the power of 6, v of 2 is 8 by 10 to the power of 6, v of 3 is 12 by 10 to the power of 6, and so on. Because once we have that function, we can then ask it for any time. So for instance, if we wanted to look at 1.5, we could put in v of 1.5 and get our exact answer. So we need some function, v of t, and we need that to be equal to some formula that describes this graph. Well, when t is 1, v is going to be 4 by 10 to the power of 6. When t is 2, it's going to be 8. So each time there's going to be some multiple of 4 by 10 to the power of 6, because that's how much it's increasing by. So it's going from 4 to 8 to 12 to 16. So what this really is 1 by 4, 2 by 4, 3 by 4, 4 by 4. So each time the minutes increase, our multiple of 4 by 10 to the power of 6 will increase by 1. So we want 4 by 10 to the power of 6 multiplied by the number of minutes, because after each minute we're going to get another 4 by 10 to the power of 6 centimeters cubed of oil. So we have this formula. Let's just check that it works. V of 1 means that t is 1, so our answer should be 4 by 10 to the power of 6, which is what we have. V of 2 should be 4 by 10 to the power of 6 times 2. That's going to be 8 by 10 to the power of 6, which is what we have. V of 3 is 3 by 4, which is 12. 12 by 10 to the power of 6 is what we have for V of 3. So here's our function, V of t. Part B. The oil spill forms a circular oil slick 1 millimeter thick. Write an equation for the volume of oil in the slick in centimeters cubed, where the radius is or centimeters. So we need to construct an equation for the volume of the oil in terms of the radius or. Now as the oil spills out, it's going to be increasing in a circle, but the height is going to stay the same. So the shape it's going to make is going to be a cylinder. So to find the volume of a cylinder, we can go to our tables book and go to page on surface area and volume. And we can see that we have a formula here for the volume of a cylinder is pi r squared h, where r is the radius and h is the height. So in this case, the height will be the height of the oil on the water, which will be 1 millimeter. And the radius r is what our function is going to be in terms of. Now we do have to be careful about the height, because the height we're given is measured in millimeters, and all of our other units are in centimeters. So we need to be careful to convert this unit from 1 millimeter into 0.1 centimeters. Okay, so we're told that the volume with respect to the radius is going to be equal to pi r squared h. Now in this case, h is going to be 0.1 centimeters. So it will be 0.1 times pi times the radius squared. So we now have a function that tells us the volume of the oil dependent on the radius. Part 2. We're asked to find the rate in centimeters per minute at which the radius of the oil slick is increasing when the radius is 50 meters. So that one sentence contains a lot of very important information. The first thing we need to see is they're asking for the rate of increase. Another way of saying that is the rate of change. And we know that whenever they ask for a rate of change, they're talking about a derivative. And it in some way relates to one or both of these two functions that we've written out already. The next thing we see is they want the rate in centimeters per minute at which the radius of the oil slick is increasing. So this is important because we're talking about centimeters and minutes. So we're relating the radius to the time that has passed. Now so far what we have is we've related the volume to the time and we've related the volume to the radius. Now they're asking us to relate the radius to the time. And the last bit of information is that we want the exact number when the radius is 50 meters. So once we've calculated the derivative that we want, then we're going to have to substitute the value of 50 meters in for the value of or. And we also need to be careful that this is in meters. All of our units so far have been in centimeters. So when we substitute, we need to use 5,000 centimeters instead of 50 meters. Otherwise, our units will be incorrect. So what we're looking for is the rate of change of the radius with respect to the time. So the thing that we're looking for is d or dt, the rate of change of the radius with respect to time. Now using the chain rule, we can relate this term to derivatives in terms of volume, because we have both of these in terms of volume, so we can calculate derivatives of the volume with respect to the time and the radius. So we can use the chain rule to say that d or dt is going to be equal to d or dv multiplied by dv dt. And the way you can remember this formula is if you think of these as fractions, which technically they're not, but you can think of them as fractions. Here we have a dv below the line, and here we have a dv above the line, so they would be cancelling out, and we're left with just d or and dt. So to calculate d or dt, we need to calculate d or dv and dv dt, and then multiply those numbers together. So the first one I'm going to calculate is dv dt, because that's the easiest one. So first, from our first formula, we have that v is equal to 4 by 10 to the power of 6 t. So then we can differentiate this in terms of t, and we get that dv dt is equal to 4 by 10 to the power of 6, because this is a constant multiplied by t, so when we take the derivative, the power of t goes down to 0, and we're left with 1. So what I mean by that is, t here is t to the power of 1. When we take the derivative of this, we multiply by 1, which doesn't change the constant, and then we reduce the power by 1. So 1 minus 1 is 0, t to the power of 0 is 1, so we're multiplying by 1 here and 1 there, so we're just left with our constant term 4 by 10 to the power of 6. Next, we want to get d or dv. Well, we can do that, but what's much easier is to get dv d or and then turn that upside down. So we have our formula, v is equal to 0.1 pi or squared. Then we can differentiate that with respect to or. So we'll have 0.1 and pi are both just constants, so they'll stay the same. Then or is what we're differentiating with respect to, so we take the power of or and we multiply by that, and then we reduce the power of or by 1, so 2 minus 1 is 1, leaving or to the power of 1. So that's going to be equal to 2 by 0.1 is 0.2 times pi times or. Now you have dv dt and dv d or, except we want d or dv. Well, d or dv is going to be equal to 1 over dv dor, which is equal to 1 over 0.2 pi or. So what we've done here is we've turned this upside down by essentially thinking of it as a fraction and dividing the top and bottom by dor. So on the top we're left with dor over dor, which is 1, and on the bottom we have dv over dor, which is what we have. So we have 1 on the top and dv dor on the bottom, which is 0.2 pi or. Now we're looking for dor dt. That's going to be equal to dor dv multiplied by dv dt. So that's going to be dor dv, which is 1 over 0.2 pi or, and that's going to be multiplied by dv dt, which is 4 by 10 to the power of 6. So this is going to be equal to 4 by 10 to the power of 6 over 0.2 pi or. We can now simplify this slightly by dividing the top and bottom by 2, and we can also multiply the top and bottom by 10. Dividing the top and bottom by 2 means this 4 is divided by 2 to get a 2, and this 0.2 becomes 0.1. If we then multiply the top and bottom by 10, this 0.1 becomes 1, so we don't need to write it down, and this 10 to the power of 6 becomes 10 to the power of 7, because we're multiplying by 10, so it's gone from 10 to the power of 6 up to 10 to the power of 7. Then on the bottom, the pi and the or remain unchanged. So we've now calculated dor dt, so we're nearly done, except we're asked to find dor dt when or is 50 meters. So we want dor dt evaluated at or is equal to 5,000 centimeters. So that's going to be equal to 2 by 10 to the 7 over pi times 5,000. So we've got 2 by 10 to the power of 7 divided by pi times 5,000. And that is equal to 1,273.2. So this is the rate at which the radius of the oil slick is increasing when the radius is 50 meters. So this is 1,273.2 centimeters per minute. Part C. Show that the area of water covered by the oil slick is increasing at a constant rate of 4 by 10 to the power of 7 centimeters squared per minute. So in this question, we're being asked about the rate at which it is increasing. Or another way of saying that is the rate of change. So again, our answer will be in the form of a derivative, something in the form of dy dx. Now we're told to show how the area is changing every minute. So we're being asked for the rate of change of area per unit time. So what that means is we're being asked to find dA dt, the rate of change of area as the time changes. So how much the area changes every time the time changes. Now using the chain rule, we can calculate that dA dt is equal to dA dor multiplied by dor dt. The way of remembering this is we can look at the dor above and below the line, and if these were fractions, the dor would cancel out and we would be left with the dA over dt, which is what we have here. Now from the previous part of the question, we know that dor dt is equal to 2 by 10 to the power of 7 over pi or. So we already know this term, and we only have to find this one. So we know d or dt is equal to 2 by 10 to the power of 7 over pi or. So now we just have to find out what is dA or, and we can multiply these two terms to get dA dt, which is what they're asking us for. To find dA or, we need some sort of way to relate how the area changes as the radius changes. And we know that the oil is spilling in a circular pattern from a central point. So we need a formula that relates the area of a circle to the radius. And we have one of those. If we look in our tables book, we will find that the area of a circle is equal to pi or squared. So this is a formula that relates the area to the radius of a circle. We can now differentiate both sides of this, get dA or is equal to 2 pi or. Because pi is a constant, so that stays the same, we take the power of the or and multiply, and then we reduce the power by 1 to be left with or to the power of 1. So dA or is 2 pi or. We now want dA dt, the rate of change of area with time. That's going to be equal to dA or 2 pi or, multiplied by d or dt, which is 2 by 10 to the power of 7 over pi or. Now we've got pi or both above and below the line, or in other words, we're both multiplying and dividing by pi or, so that will cancel out. So we're left with 2 times 2 times 10 to the power of 7. And we can multiply this 2 by 2 to get 4 by 10 to the power of 7, which is what we're asked for. We're told to show that the rate of change is 4 by 10 to the power of 7 centimeters squared per minute. Part D. The nearest land is 1 kilometer from the point at which the oil spill begins. Find how long it will take for the oil slick to reach the land. And then we want our answer correct to the nearest hour. So what we're being asked for is to find how long it will take for the radius of the oil slick to be 1 kilometer long. In other words, we're being asked to relate the time to the radius. Now what we've just done is related the area to the time, and we know how to relate the area to the radius. So if we can get A as some function of time, we can equate that with this term here, because A is also equal to pi or squared. So we know that dA dt is equal to 4 by 10 to the power of 7. So if we integrate this, we'll have the integral of dA is equal to the integral of 4 by 10 to the power of 7 dt. So what we've done here is we've multiplied both sides by dt, so that dt comes over here and the dA is left by itself. Then we integrate both sides, and here we've got the integral of dA, which is just a, is equal to the integral of some constant times dt. Well, the constant doesn't matter because it's integration, so this is just the integral of dt, which is t. So a is equal to 4 by 10 to the power of 7 times t. We now have a as a function of time, and we already have a as a function of radius. So we know that a is equal to pi or squared, and a is equal to 4 by 10 to the power of 7t. Therefore, t times 4 by 10 to the power of 7 has to be equal to pi or squared, because both of these are equal to a. We can then divide both sides by 4 by 10 to the power of 7 to get that t is equal to pi or squared over 4 by 10 to the power of 7. Now we want to find the value of t when or is 1 kilometer, and we need to be careful because our units for or have to be centimeters, and they're given to us in kilometers. So instead of 1 kilometer, we need to use 100,000 centimeters. So when or is equal to 1 kilometer, it will be equal to 1,000 meters, which will be equal to 100,000 centimeters. Then T will be equal to pi times or, which is 100,000, or 10 to the power of 5, squared, divided by 4 by 10 to the power of 7. Now this is going to be equal to 10 to the power of 5 squared is 10 to the power of 10, and that divided by 10 to the power of 7 leaves 10 to the power of 3. So that will be pi times 10 to the power of 3 divided by 4. Now 10 to the power of 3 is 1000, divided by 4 is 250. So the time will be 250 pi minutes. Now they want the time to the nearest hour. So we have 250 pi, which is equal to 785.398 minutes. We can then divide that by 60 to get 13.09 hours, which we round to 13 hours. So the oil slick will reach land after 13 hours. Question 9. The approximate length of the day in Galway, measured in hours from sunrise to sunset, may be calculated using the function f of t is equal to 12.25 plus 4.75 sine of 2 pi over 365 t, where t is the number of days after March 21st, and 2 pi over 365t is expressed in radians. So it is important that before we start this question, we note that this value is expressed in radians, so we need to make sure our calculators are in radian mode. That means you can't use degrees for this question, because if you do, your answers will be incorrect. Now what this function tells us is that the length of the day, f of t, can be calculated using this function if t is a number of days after March 21st. Part A, we're asked to find the length of the day in Galway on June 5th, which is 76 days after March 21st. We're then asked to give our answer in hours and minutes correct to the nearest minute. So, when t is equal to 76 days, we have f of 76, which will be equal to 12.25 plus 4.75 times sine of 2 pi over 365 multiplied by t, which is 76, so multiplied by 76. So we have 12.25 plus 4.75 multiplied by sine of 2 pi divided by 365 multiplied by 76. And it is very important here that our calculator is in radian mode, because otherwise our answer will not be correct. So the length of the day will be 16.837 hours. But we've been asked to give our answer in hours and minutes correct to the nearest minute. So we don't just want it in hours, we want it in hours and minutes. So if we subtract 16 here, then we'll have 0.837 hours is the number of minutes. So if we multiply that by 60, we'll get the exact number of minutes. So this is equal to 16 hours and 50 minutes when we round it to the nearest minute. Part B. Find a date on which the length of the day in Galway is approximately 15 hours. So what we're being asked to do here is find a value of t such that f of t is equal to 15 hours. Now we know what f of t is, it's this function. So if f of t is 15 hours, then 15 is equal to the function 12.25 plus 4.75 sine of 2 pi over 365 times t. Now all we have to do is solve this equation for t, and we'll have the number of days after March 21st when this happens. So the first thing we want to do is we want to subtract 12.25 from both sides. So 15 minus 12.25 is 2.75, which is equal to 4.75 sine of 2 pi over 365 t. We can then divide both sides by 4.75, so 2.75 divided by 4.75 gives us 11 over 19, which will be equal to sine of 2 pi over 365 multiplied by t. We then want to bring this sine over to the other side of the equals, so we take sine inverse of both sides to get sine inverse of 11 over 19 is equal to 2 pi over 365 multiplied by t. Next we want to get t by itself, so we multiply both sides by 365 and divide both sides by 2 pi to get that t is equal to 365 sine inverse of 11 over 19 over 2 pi. Again, when we type this into the calculator, it's very important that our calculator is in radian mode, otherwise we will get the wrong answer. So we want to type in 365 over 2 pi times sine inverse of 11 over 19. Which is equal to 35.868 days after March 21st, and we need it to the nearest day, so that's approximately equal to 36 days after March 21st. Now they're asking us specifically to find a date on which the length of the day in Galway is that long. So we need to calculate what date is 36 days after March 21st. Well, March has 31 days in it, so 31 days after March 21st will be April 21st, and 5 days after that will be April 26th. So the answer is on April 26th, the day will be 15 hours long. Part C, we're asked to find f dash of t, the derivative of f of t. So we know what f of t is. F of t is equal to 12.25 plus 4.75 sine of 2 pi over 365 times t. Now to take the derivative, first thing we need to know is that all constant terms, that is any term without a t in it, goes straight to 0. So this 12.25, that's going to be 0. That's not going to affect our answer. Next we have this term here, 4.75 sine of 2 pi over 365 times t. To differentiate this, we're going to have to use the chain rule, because we're going to differentiate sine and then multiply by the derivative of what's in these brackets here. So the first thing is, this is a constant times some term that won't disappear, so the constant stays the same. So we have 4.75. Then we want to differentiate sine. The derivative of sine is cos. So that is cos of 2 pi over 365 times t. And then we want to multiply by the derivative of what's in the brackets here. So 2 pi over 365 is a constant, so that stays the same. When we differentiate some number of t, that just means the t disappears and we're left with the constant. So we want to multiply by 2 pi over 365. We now want to multiply 2 pi over 365 by 4.75 to get 9.5 pi over 365 times cos of 2 pi over 365 times t. So there is the derivative of f of t, f dash of t. Part D. Hence or otherwise, find the length of the longest day in Galway. So what they're asking us for here is what is the maximum value of the function f of t. And whenever we want to find a maximum or minimum value for a function, what we want to do is we want to get the derivative of that function and find where that derivative equals 0. So we know that f of t is equal to 12.25 plus 4.75 sine of 2 pi over 365 times t. And we recently just calculated that f dash of t is equal to 9.5 pi over 365 times cos of 2 pi over 365 times t. So we know both the function and the derivative. So we want to see what is the largest value of f of t, and to calculate that, we can set f dash of t equal to 0, because this will show us any local maxima or minima. So when f dash of t is equal to 0, that means that 9.5 pi over 365 times cos of 2 pi over 365 t is equal to 0, because f dash of t is equal to 0. Then we can multiply both sides by 365 and divide both sides by 9.5 pi, and we get that cos of 2 pi over 365 times t is equal to 0. We can then take cos inverse of both sides to get that 2 pi over 365 times t is equal to cos inverse of 0, and cos inverse of 0 is equal to pi over 2 radians. We can then divide both sides of this by pi, so we have that 2 over 365 times t is equal to 1 over 2. We can then divide both sides by 2 and multiply both sides by 365 to get that t is equal to 365 over 4. 365 divided by 4 is equal to 91.25. So the value of t, for which f of t is maximum, is 91.25. But we haven't been asked for the value of t, we've been asked for the length of the longest day. So we know that that day is 91.25 days after March 21st, but we haven't yet calculated what is the actual length of that day. So we have to calculate f of 91.25, because this will be the length of the day that is 91.25 days after March 21st, which is the day we've just calculated as the longest. So that will be equal to 12.25 plus 4.75 times sine of 2 pi over 365 multiplied by t, which in this case is 91.25. So that will be 12.25 plus 4.75 times sine of 2 pi over 365 multiplied by 91.25. And again, we need to make sure that our calculator is in radian mode. And the answer is 17. So the length of the longest day will be 17 hours. Part E. Use integration to find the average length of the day in Galway over the 6 months from March 21st to September 21st. It tells us that's 184 days, and we have to give our answer in hours and minutes, correct to the nearest minute. Okay, so what we have here is we have a function which tells us the length of the day. So if we were to graph this function, we would have something like this, and we would have our x-axis down here. And the height of this graph will tell us the length of the day. So if we go here, the length of the day will be over there, or if we go here, the length of the day will be over there. So for this day, there will be the length of the day. So if we want to find the total amount of daylight time over a certain period, what we want is the area under this curve at all points. So what we're looking for is the area under this curve, which we can find by integrating the curve f of t with respect to t. And we want to integrate it over 184 days. So from 0 to 184, and that will be the total amount of daylight in that period of time. But we're not asked for the total, we're asked for the average. So to get the average amount of time, we want to divide this number by the number of days there are, which is 184. So we want to have 1 over 184 multiplied by this value, and that will give us the average amount of daylight time in a single day over that period of time. So we want to calculate 1 over 184 times the integral from 0 to 184 of our function f of t, which is 12.25 plus 4.75 times sine of 2 pi over 365 times t. And we're integrating with respect to t. Now the first thing we notice is this part here is a constant, so we can take that outside of the first integral. We also notice that this is the integral of the sum of two things, so to calculate that, we can integrate each thing separately. So this will be equal to 12.25 over 184 times the integral of dt from 0 to 184. That's the first part. And then plus 4.75 over 184 times the integral from 0 to 184 of sine 2 pi over 365 times t with respect to t. So there is the second part. So all I've done here is I've applied this integral to both parts of the sum, and then I've taken the constants 12.25 and 4.75 outside of the integral because they won't affect the final value. Now when we're integrating dt, that evaluates just to t, so this will be equal to 12.25 over 184 times t evaluated from 0 to 184. To that we're going to add on 4.75 over 184 times the integral of this evaluated from 0 to 184. Now when we want to integrate sine of something what we want to do is we change that from sine to minus cos. This will be minus cos of 2 pi over 365 times t. When we differentiate, we want to multiply by the derivative of what's in here. So because we're integrating, we instead want to divide by the derivative of what's in here. So the derivative of 2 pi over 365 times t will just be the constant 2 pi over 365. And because we want to divide by that, that's the same as multiplying by 365 over 2 pi. And that's going to be equal to 12.25 over 184 multiplied by 184 minus 0. So this value is in here is just going to be 184. So that will be 12.25. Then here we're going to be able to bring all of the constants outside of these brackets. So this will be minus 4.75 times 365 over 184 times 2 pi multiplied by cos of 2 pi over 365 times t. And that will still be evaluated from 0 to 184. So that is going to be equal to 12.25 minus 4.75 times 365 divided by 2 pi divided by 184, which is going to be 1.4996. And that will be multiplied by the evaluation of this from 0 to 184. So that's going to be cos of 2 pi divided by 365 multiplied by 184, which is going to be cos of 368 pi over 365 minus this evaluated at 0, so this will be 0, so this will be the cos of 0. Cos of 0 is equal to 1. So that's going to be equal to 12.25 minus 1.4996 times cos of 368 pi over 365 minus 1. And that will be equal to 15.2487 hours. And they want our answer in hours and minutes, correct to the nearest minute. This is approximately 0.25. A quarter of an hour is 15 minutes. So this will be 15 hours and 15 minutes. And we're done. This has been the Leaving Cert Higher Level Mathematics Exam, Paper 1 from 2015. If you found this video helpful, please go to my channel for more fully worked solutions to both Junior Cert and Leaving Cert Mathematics exams.